everyone, welcome to homework video 1.12. I'm going to start with going over the classwork problems and reviewing how to use your graphing calculator, and then I'll get into the homework. All right, so we have a dining hall that has a total of 25 tables, some long rectangular tables and some round ones. And so the long tables can seat 8 people, and the round tables, come on now, there we go, okay, can seat 6 people. On a busy day, all 190 seats at the tables are occupied. So we need to make two equations. So first it says write the equation to show the total number of tables. So we have total of 25 and two types, the long x and the round ones y. So x plus y equals 25. All right, again, the x represents the number of long tables, the y represents the number of round tables, and in total we know that there's 25 based on what we're given here. Then it says write the equation to show the number of seats. So given the number of seats, we have 8 people or 8 seats per long table. So that's 8 times x, 8 times the number of long tables, plus 6 times the number of round tables equals a total of, you can't really see that, a total of 190 seats. So then we have a second equation. So now we've created a system of equations in which we have two equations representing this one situation of tables and seats. Okay, so remember x and y represent the number of tables, the number of long tables, and the number of round tables. And if we want to graph that, we're going to need to put this in y-intercept, slope-intercept form. Now, if you were to use Desmos, you can just type in the equation as is. So if you want to check your work, you can do that. The reason I'm insisting that you use your TI-84 is because that's what you are allowed to use on the PARCC test, and so you want to feel really confident using that. So we're going to start by solving for y here, and so I'm going to subtract x on both sides, and we will get y equals negative x plus 25. That's our first equation, so I can go ahead and put that in, negative x plus 25. That's the first equation. Now the second equation that I'm going to do is from this one, and that's going to take a little bit more work. So I'm going to actually move to, let me see if I can do this accurately, to another screen so that you can see me do the work. Maybe if I can find here it is. Okay. All right. So we have 8x plus 6y equals 190. Now, I'm showing my work because I really want you to show your work on your paper. So, again, this is 190 minus 8x, or negative 8x, plus 190. Divide both sides by 6. And we get y equals negative. Now, we can reduce this here to 4/3 x plus, and I'm going to say leave your 190 divided by 6 as it is, okay? Because it's just going to end up helping you in the long run. All right, so let's go ahead. Let me just make sure I did, okay, I did set up the equation correctly. All right, so we're going to say that y equals then negative 4/3. So alpha y equals, we can do fraction. All right, 4/3x plus, again, alpha, y equals, to do our fraction, and then we have 190 over 6. All right, so then I'm going to press graph. Now what you might notice here is that our graph isn't like really on there, so we're going to press zoom and choose zoom out, and when you do that, you need to press enter to have it actually zoom out some more. So let's do it again. All right, so now we can see a little bit better where that point is. So to calculate the intersection, and I'm going to go ahead and do second calc, and then 5 as intersect. Left bound, we hit enter. Right bound, I'm going to move to the right. Boop, 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 boop. Just use your arrow keys. Enter, and then it gives me the intersection of x equals 20 and y equals 5. So this means we have 20 long tables and 5 round tables. So then what you need to do is you need to sketch this on your graph. Now it doesn't have to be exact because these are pretty large numbers, but let's say we have 5 let's do it by 5. So 5, 10, 15, 20, and then 5, 10, 15, 20 if you count by 20s. And we know our intersection is at x equals 20 comma 5. So this is the intersection of the two lines. And so then you can go ahead and draw your one line. I didn't even make it through. That was not so great. Let's try that again. One. Come on, there we go. And then your other line, which is going to also have a negative slope slightly going through that. But that's the point, that they intersect is 20 comma 5. Okay? All right, so now we have a similar situation, except now we're talking about tickets and money, all right? But you're going to have not perfect equations here. So we're going to have, we're going to make our A value here x and our C value y for the sake of graphing, okay? And so you're going to have x plus y equals 16 tickets, because we have a total of this tickets, and then 1050x, which is your adult ticket price, plus 750y, your child ticket price, equals 141. Now, same thing, I need to go ahead and let's go to our y equals. Let me clear out our previous ones. And we need to put this as in slope-intercept form. So this one, if we subtract x from both sides, we'll get y equals negative x plus 16. So negative x plus 16 is our first one. The second equation, again, let's see if I can hopefully remember all of that information here, is 1050, okay, here we go. 1050x plus 750y, 750y equals 141. All right, solving for y now. I'm going to subtract 1050x on both sides. We get 750y equals negative 1050x plus 141. Divide both sides by 750. And so now you can put in your y equals negative 1050 over 7.5x plus 141 over 7.5. And you can just leave it like this. That's perfectly fine, because if you try to divide your fractions, you're going to have not the best experience there, okay? So in my calculator, I'm going to insert negative alpha y equals fraction. Put the fraction in, 1050 over 7.5. Don't forget the x, plus alpha y equals fraction 141 over 7.5. Okay, so yours should look like mine. Remember, if we're doing a negative, you're using that negative down at the bottom instead of your minus sign. Press graph. Okay, so now we have a graph, and it is actually already giving us an intersection, but I think that might be from the last one, so let's just verify that here. We're going to do second calc, and you're going to choose 5, intersect. All right, our right bound, enter, and then left bound. Oh, what happened? Something not great happened, so let's try that again. 5, because there's clearly an intersection. Left bound, and I think, fuck, I messed up. Right bound, there we go. Oh, there it is. The intersection is 7, 9. All right, so let's go back to our Word document here, and we'll put our calculator. There we go. All right, so we have 7, 9 here. And so again, you can just kind of estimate on your graph. It doesn't have to be perfect where that would be. So let's say you go 1, 2, 3, 4, 5, 6, 7, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9. This is where they intersect, and then our one line is like this, the other line's like that. They're both negative slopes, so your graph should look something like that as well. All right, and then you can also verify 7 plus 9 does in fact equal 16, so that works. And then if you were to plug in 7 plus 750 times 9, you should get 141, and so you can make sure that that answer is accurate. And remember, in order for them to be solutions, they have to work for both. Okay, let's take a look at the actual homework. So the Knitting Club sold 40 scarves and hats at a winter festival and made $700 from the sales. 40 scarves and hats, $700. They charged $18 per scarf, $14 per hat. All right, so I know that we have scarves plus hats gives us a total of 40. That's the number. Now we're looking at the cost. So 18 times the number of scarves plus 14 times the number of hats equals $700. That's how much they made. So those are the two equations I'm looking for, and I'm going to see if I can find one here. So A, we don't have any, first of all, we have 40 in front of the S, and that's talking about the number of scarves, not the number of scarves and hats, right? And so it shouldn't be with the S here. That doesn't make sense. That doesn't work out. B matches very closely, except we have the wrong values here. So here it says that the cost, where 18 and 14 are given, gives us 440, and that's not the cost or the total sales. That's the number of scarves and hats, so that one doesn't work. S plus H equals 40, and then 18S plus 14H equals 700. This matches up nicely. The first equation gives us number of scarves and hats, and the second equation gives us the cost or the amount that was made based on the cost of the scarves and the hat. So that one makes the most sense. All right, so letter C there. All right, number 2 says here are two equations. Determine whether x, y is a pair to one equation, both equations, or neither of the equations. So your job here is to plug these numbers into the equations and see if they work. So I'm going to do an example with this first one, but you need to do it for each one of these. So if we do 6 times 3 plus 4 times 4, and remember this is the x, y, this is the y, so you're plugging that in, equals 34. We get 18 plus 16, and 18 plus 16 does equal 34. So this works for the first equation. And then let's try the second one and see if it works. So the second equation says 5 times 3 minus 2 times 4 equals 15. This is 15 minus 8 equals 15. That is not true. So first only. So that's what you're doing for each ordered pair. So you're going to go to the next ordered pair, and you're going to go ahead and try 4 and 2.5. So 6 times 4 plus 4 times 2.5 equals 34. You'll get 6 times 4 is 24, plus 4 times 2.5 is 10, equals 34. That is true. So far the first works. Let's try the second one. Plugging in 5 times 4 minus 2 times 2.5 equals 15. We get 20 minus 5 equals 15. That is in fact true. So first and second equation. All right, done. So now your job is to do 3 and 4. You can do that. You're just going to follow the same thing that Miss Lee did. See which of those ordered pairs works in each of these equations. You need to do this on paper, not in your head, okay? Because you want to make sure, some of you are making very small calculation errors because you're trying to do it all in your head. Put it on the paper. All right. Is it possible to have more than one XY pair that is a solution to both equations? Explain or show your reasoning. Okay, so you want to try to figure out, is it possible that these two equations could have more than one ordered pair that works for both equations? Yes or no? I'm going to tell you that the answer is no. But I want you to explain why and think about it in terms of the graph. How many times do they intersect? Okay? All right. Number 3 says, explain or show that the point 5 comma negative 4 is a solution to the system of equations. So to prove this, we're going to plug in 5 and negative 4 to x and y for both equations. So 3 times 5 minus 2 times negative 4 equals 23. We get 15. Negative 2 times negative 4 is positive 8 equals 23. So we can see that that works for the first equation. The second equation is 2 times 5 plus negative 4 equals 6. We get 10 plus a negative 4 is minus 4 equals 6. That is also true. So that's all you have to do to show that this point is a solution to the equation because it works. in both equations. All right. Number 4, Diego is thinking of two positive numbers. He says if we triple the first number and double the second, the sum is 34. So if we triple the first number, 3x, and we double the second number, the sum is 34. Okay. Diego then says if we take half of the first number and double the second number, the sum is 14. Okay. So we have two equations now. What are the two numbers? And it says explain or show how you know. So you can either explain, you can give me a written explanation, but I would use this graph here to show me that. And what you're going to do is let's do what we do and solve for y. So we'll subtract 3x from both sides. You'll get 2y equals negative 3x plus 34. Divide both sides by 2. And you'll get y equals negative 3 over 2x plus 17. So you can graph that, and so you can show here if we have 17, we're going down 3 over 2, 1, 2, 3, and then over 2, down 3, 1, 2, 3, and over 2. All right, so you're going to graph that equation there. And then the other one, we're going to solve for y as well. So you'll get y equals negative 1/2 x plus 14 divided by 2. So when we divide a fraction, 0.5 divided by 2, you're going to end up with a negative 1/2 divided by 2 is the same as negative 1/2 times 2 over 1, right? We're multiplying by the reciprocal. This then is going to end up being negative 1. So we're going to get y equals negative x plus 7. So we can start at 7, and then we're doing down 1 over 1. Right, so down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and so forth and so on. And so if you continue that graph down, let's continue this one as well. Down 3, 1, 2, 3, and over 2, 1, 2, 3, and over 2, 1, 2, 3, and over 2. Okay, so this is a learning example because I made a mistake. Let's go back. All right. Rewind. Okay, this is also why you need to show your work. My first equation's good. Second equation, I messed it up. So let's take a look at it. See, again, this is why we show our work. So the second equation says 1/2 x plus 2y equals 14. I'm going to go to my workspace so we don't have this issue again. 1/2 x plus 2y equals 14. Okay, there's a couple things that we can do here. And what I showed you before is I subtracted 1/2 x from both sides. So let's go ahead and do that. Negative 1/2 x plus 14. And now we need to divide both sides by 2. So where I messed up here is y equals negative 1/2 x divided by 2 should look like this. Negative 1/2 x, multiply that by the reciprocal times 1 over 2. So what I did is I multiplied by 2, and that was incorrect because we're dividing by 2. So when you divide by 2, you multiply by the reciprocal, so times 1 over 2. And so that is going to give us negative 1/4 x plus 14 divided by 2 is 7. Okay, so now we have this new equation, and that's going to help us out a lot. So let's go back. So if this second equation is 1/4 x, negative 1/4 x plus 7, and then again, I'm starting with my y value of 7, my y-intercept of 7, but I'm going down 1 over 4. So we're going down 1 over 4, down 1 over 4, and we see right here, let me change color so you can see better. Here, here, down 1 over 4, down 1 over 4, down 1 over 4, down 1 over 4. So now this line is going to be here. The pink line is coming down like this. And so this is where that intersection is. So that intersection happens at 8, 5, it appears. All right, and we can double check and make for sure that that is what it is by graphing it. All right, so let's try that. We're going to do alpha y equals fraction 1 over, oops, nope, sorry. That has to be a negative. See, negative 1 over 4x plus 7 is one of our equations, and then negative alpha y equals, set up our fraction. We have 3 over 2x plus 17, graphing it. All right, now we're going to do second calc. I'm going to calculate my intersection here. Let's go left bound, enter, right bound, enter, and our intersection is 8, 5, so we got that correct, okay? So, again, my bad, y'all, when you divide by fractions, be very careful. 1/2 x divided by 2 is the same as 1/2, or in this case, negative 1/2 x times 1 over 2. Okay, be very careful with that. I am going to show you real quick too, as I was doing this, another way that I might have handled that would have been helpful is 1/2 x plus 2y equals 14. We can also go ahead and get rid of the denominator by multiplying the whole thing by 2. This will give you x plus 4y equals 28. And then we can minus x on both sides. You get 4y equals negative x plus 28. And if you divide both sides by 4, you'll get y equals negative 1/4 x plus 7. So we get the same answer this way. So that's another way to handle this. If you have a denominator that you want to get rid of and make your life a little bit easier, you can go ahead and do it that way as well. Okay, so just so that you can see that, be very careful. See, Miss Lee made a mistake. It's okay. Figured it out. Knew that didn't look right. All right. So this bottom part, I'm only going to model one of them for you because the rest you can do by yourself. This is just review. They are already put into slope-intercept form. So all you need to do is find your y-intercept, right? That's 3 here. And then we're going negative, so it needs to go down 5, 1, 2, 3, 4, 5, and then over 3, 1, 2, 3. Okay, so all you're doing here is plotting points, drawing your lines, and showing me where these two equations intersect to find the value. You can use your calculator if you'd like to, but these are all easy for you to graph by hand. Okay, so you're fully capable of doing that. Start with the y-intercept and then use your slope to plot the other points. I recommend if you have another color at home to use 2 different colors to help you differentiate. I am going to give you a little hint for number 4. You have this y equals negative 1, and a lot of times this trips kids up. But y equals negative 1 means that anywhere that x is, no matter what value x is, y is going to equal negative 1. And what that's going to create for us is a horizontal line here. So that's the first line for that, and I'll show you if you were to plug it into your calculator, right? If you were to put in negative 1 here and then do graph, you see it gives you just a vertical or a horizontal line going across like that. All right, and so then you'll graph this one. Start with your y-intercept of 4. It's going this way, and so down 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. Right, and so already you can see the point of intersection is here. All right, so these other ones you can do by yourself. I know you can do them, and it's good practice for you in terms of graphing. If you have any questions, please let me know. Your code word for today is mistake, because we learn from mistakes. Happy homeworking, and see you tomorrow.